Hi everyone, in this video we are going to continue solving quadratics. We are going to work with a different method though, called the quadratic formula. In this video you will learn how to determine the discriminant of a quadratic equation. You will use that discriminant to describe the nature of the quadratic equation's solutions, and then you will use the quadratic formula to actually find the roots of the quadratic equation. Okay, so let's talk about the discriminant first. The discriminant is a nice number that's going to tell us how many roots or how many x-intercept a quadratic equation is going to have. So when you look at standard form, remember standard form is this form here. You first need to look at A, B, and C. So A in this first problem is 1, B is -2, and C is 0 because there's no constant term being added on to the end there. When you know these three coefficients, then you can calculate the discriminant by using this formula. We're going to take B and square it, and then subtract from it 4 times A, which is 1, times C, which is 0. So -2 squared is 4, and when you multiply anything by 0, it just gives you 0. So the discriminant of number 1 is 4. Notice for this one, I have a discriminant of 4. How many x-intercepts are there? How many solutions? There are 2 there. We'll come back to that idea in a moment after we look at a few more. Look at g of x, number 2. A is -1, B is +2, and C, because there's no constant term there, is 0. Calculating the discriminant, B squared is 2 squared, and then we're subtracting 4 times -1 times C, which is 0. That gives us 4 minus 0. We again get 4 for this one. Looking at the graph, notice that there are 2 x-intercepts. Okay, let's look at this next one, h of x. A is -1, B is 2, and C this time is -1. Plugging that into our discriminant formula, B squared is 2 squared minus 4 times -1 times -1. That gives us 4 minus -4 times -1 is +4. And then I need to multiply that by -1, so that's 4 minus 4. I got 0 as my discriminant. Notice for number 3, there is only 1 x-intercept. And looking at number 4, the A is 1, B is -2, C is 2. Plugging those values into the discriminant, I've got -2 squared minus 4 times 1 times 2. That is 4 minus 4 times 2 is 8, which means my discriminant is -4. Notice for that one, there are no x-intercepts. Okay, so let's figure out a pattern here. When you look at the first 2 problems, you got a discriminant that is larger than 0. It's equal to 4. How many solutions did you have in both of those graphs? There were 2 x-intercepts, so that means there were 2 solutions. This is going to be generally true when the discriminant is greater than 0, meaning that it's a positive number. You are going to have 2 real solutions, meaning there are 2 solutions, 2 answers, and they are real. They cross the x-axis. Let's look at number 3, where the discriminant was equal to 0. In number 3, with the discriminant of 0, how many solutions were there? There's only 1 x-intercept. That means there is 1 real solution when the discriminant is equal to 0. 1 tells us the quantity of x-intercepts. Real tells us that it is indeed crossing the x-axis. All right, let's look at this next one. When the discriminant is less than 0. So that means we're talking about the discriminant being a negative number. That was like number 4. In number 4, we got a discriminant of -4, and notice that there were no places where the parabola crossed the x-axis. So there were 0 real solutions. Now recall from when we did the square root method, just because there are no real solutions doesn't mean that there are no solutions. It means that there are two imaginary solutions. Anytime you have a parabola that does not cross the x-axis, there will be two imaginary solutions, no real solutions, and it means the discriminant is a number smaller than 0 or negative number. So when you calculate the discriminant, whatever it's equal to, whether it's a positive number, 0, or a negative number, that will tell you what's called the nature of the solutions. The nature of the solutions is two pieces of information. It's how many, and it's what kind of number. And by what kind of number, I mean real versus imaginary. Okay, so let's look at the quadratic formula now. The discriminant is a part of the quadratic formula. The quadratic formula, if you have an equation in standard form, meaning you have a, b, and c, is this guy here. The solutions, the x-intercepts, are equal to what happens when you plug in a, b, and c from standard form, those coefficients. Now, I do want you to notice inside of this quadratic formula, do you see the part that is inside of the square root? Notice anything interesting about that part? That expression inside of the square root is the discriminant. So we are going to use the discriminant to find the quadratic formula's solutions. And that will also mean that when we calculate the discriminant, you should immediately know the nature of the solutions, how many and which type of numbers the solutions are. So let's look at an example of solving with the quadratic formula. The first thing you're doing, because we're trying to find the x-intercepts, is set the equation equal to 0, which means I need to subtract 4 on both sides. That gives me x squared minus 5x minus 4 is equal to 0. So now I'm ready to solve this quadratic equation. You should always look to see if you can factor the polynomial, because if you can factor, that offers you more options for how to solve it. You can use the quadratic formula to solve any quadratic, but often it's not the easiest method to use because it is kind of cumbersome. There are a lot of little details that you have to be sure to get right. So this polynomial, to get 4, I can do 1 times 4 or 2 times 2, but using different signs, none of those add up to negative 5. So this one is a prime polynomial. That means I can't factor it, so that step is out. It cannot be factored. So now I need to calculate the discriminant. That will tell me the nature of my solutions, and it will also help me plug into the quadratic formula. So the discriminant is b squared minus 4ac. Remember, I got that from this highlighted part of the quadratic formula. That means b is negative 5, so I'm doing negative 5 squared minus 4 times a, which is 1, times negative 4, which is c. Negative 5 squared is 25, and then negative 4 times negative 4 is positive 16, which means my discriminant is 41. Now, according to that summary we just did a minute ago, when we got the discriminant is 41, that's a positive number. So because it's a positive number, that means there are going to be two real solutions. We are not going to have any imaginary numbers in our answer. Okay, so now let's plug a, b, and the discriminant into the whole quadratic formula. So x is equal to negative b. B was negative 5. Be sure you have this negative 5 here, plus and minus the square root of the discriminant. Now we've already calculated that, so I'm just going to write 41 there. I'm not going to recalculate something that I've already worked so hard to get to. And then the rest of the formula says that I have to divide that whole thing by 2 times a, which is 1. All right, so let's simplify this thing. Negative 5 is just positive 5. So that's 5 plus or minus. I can't simplify the square root of 41. 41 is just 1 times 41, and that's all over 2. From there, there's no further simplifying that I can do. The radical is simplified. This fraction can't be reduced. So that is my final answer. If there was something that did need to be simplified in here, either the radical or a fraction outside, then you would need to continue working to simplify this answer. But as it is, we have 2 real solutions here. All right, I would like for you to try the Now You Try Now. You are going to be determining the discriminant. You should be able to describe the nature of the solutions for the quadratic equation using the discriminant, and you should be able to plug in values to the quadratic formula to find those roots or solutions.